What if a lone aircraft could destroy a Russian warship without relying on speed, stealth, or the element of surprise? At 7:18, a Russian patrol vessel in the Caspian Sea detected a small contact on its radar. The return appeared at approximately 14 kilometers, flying low, below 40 meters, and moving at a steady 150 kilometers per hour. It was too slow to be a missile and too stable to be atmospheric clutter. The bearing was constant, the track was clean, and the object was closing in. The ship's combat system reacted automatically. Fire control software began calculating an intercept. The close-in weapon system on the bow adjusted its orientation. It aligned itself with a predicted engagement point. No alarms sounded. No emergency procedures were triggered.
On Sector Gamma.
At that distance, against a slow target, the situation appeared manageable from the bridge. This was not yet a crisis. The target was exposed, the ship was ready, and there was still time to act. The assumption was simple. If it came closer, it would be destroyed. What the crew did not know was that this contact had already bypassed layers of defenses designed to stop it long before this moment. Its approach angle forced the ship's weapon to operate at the edge of its firing geometry. In this zone, tracking was possible, but engagement was uncertain. It did not slow down. It kept moving straight towards the ship. In those few seconds before any shot was fired, the outcome was already being shaped. Not by reaction time or firepower, but by geometry. At 7:28, the moment the contact crossed the 11-kilometer mark, the ship committed to an intercept. Fire control radar locked firmly onto the target. The object was flying below 35 meters, holding a steady speed of roughly 150 kilometers per hour on a direct bearing. The combat system classified it as hostile based on behavior and initiated engagement calculations. At just under 10 kilometers, the close-in weapon system transitioned from tracking to firing logic. A short burst was fired. The gun released about 150 rounds in less than 2 seconds, aimed at a predicted intercept point. Tracers streaked across the air ahead of the target. There was no detonation and no visible damage. The radar track remained stable, continuing forward without deviation. The system recalculated and attempted to re-engage. The gun followed the contact precisely, but the solution remained unstable. The target repeatedly slipped outside the engagement envelope. It stayed visible and trackable, yet never long enough inside the firing arc to allow a sustained burst. A second intercept attempt was prepared at closer range. Again, the contact rode the outer edge of the weapon's engagement geometry. The gun could see it and the radar could track it, but the weapon could not remain aligned long enough to deliver a decisive hit. The range decreased to 8 kilometers. At this point, the failure was no longer tactical. The system was operating correctly. The limitation was purely geometric. A narrow firing envelope was being exploited by a slow, precise approach. The ship's options were narrowing. If the weapon could not reach the target, the ship would have to change the geometry itself. That decision was already forming, and it would define the next phase of the engagement. At 7:36, the target crossed 7 kilometers, still flying below 30 meters and holding a perfectly steady approach. Fire control radar tracked it cleanly, updating dozens of times per second. On every display, a solution existed. The numbers were correct. The problem was mechanical. The close-in weapon system tried to follow the bearing through 268 degrees. The gun had reached its physical limit, blocked by the ship's own structure. It could not rotate further without firing into its own steel. The computer kept recalculating, but each cycle ended the same way. Boundary violation, loss of solution, instant reacquisition. Automation was working perfectly, yet achieving nothing. The order to maneuver came immediately. The ship turned hard to port. Engines increased power as hundreds of tons of hull rotated through the water. The intent was simple: rotate the ship to pull the target into the firing arc and erase the blind sector. But the blind sector rotated with the ship. The target did not adjust its course. It stayed locked to the boundary, sliding along the edge of the engagement envelope as if guided by it. At 5 kilometers, the firing solution briefly turned green. The gun fired a short burst of nearly 200 rounds toward a point the target had already passed. During the firing sequence, the bearing shifted by just a few degrees. It was enough to miss. At 3 kilometers, there was no more time to correct. The weapon tracked. The ship turned. Then the drone reached the limit of geometry. It did not evade. It did not slow. It flew straight into the ship's superstructure and detonated on impact. The explosion tore through external plating and ruptured internal systems. Fire spread across compartments before damage control could react. Seconds later, the engagement was over. The weapon had seen the target the entire time. It simply could not shoot where the target chose to be. Hours earlier, far from the Caspian Sea, the mission nearly ended before it truly began. In the early morning darkness, a Ukrainian air defense unit detected 2 low, slow contacts approaching from the northwest. The radar picture was familiar.
On target.
Altitude around 180 meters,
check the firing
speed near 145 kilometers per hour. The flight profile matched the drones the crew had been tracking all week. The system flagged them automatically. The threat logic was clean. Too clean. The fire control officer leaned forward as the clock started to compress. Target range, 42 kilometers.
Track confirmed on the target
Time
icon.
to engagement
It's moving
window,
along the boundary.
under 20 seconds.
Acknowledged.
The launcher was
Keep
powered
monitoring the gap.
and guidance parameters were loaded. The crew had done this dozens of times before. No hesitation, no confusion. The contacts were flying straight and disciplined, almost careless. That alone made them suspicious. The countdown reached 10 seconds. At 7 seconds, the officer cross-checked the altitude and heading again. The numbers were precise, almost identical to hostile profiles. At 5 seconds, his hand hovered over the authorization. Then, one line of data broke the pattern. The flight path intersected a protected corridor, Corridor 7, active for a narrow window that night. This was a strip of airspace less than 15 kilometers wide, reserved for special operations flights. These flights were never acknowledged on the radar picture, unless someone actively looked for them. The realization landed instantly. These were not incoming threats. They were outbound assets. The authorization was pulled back with less than 3 seconds remaining. The launcher stood down. The radar continued to track as the 2 contacts passed through the corridor and disappeared to the southeast. They never knew how close they had come to being destroyed by their own side. The margin was measured in seconds.
We're losing an engine.
The consequence would have been absolute. That single decision made under pressure allowed the drones to continue into hundreds of kilometers of hostile airspace. Every event that followed depended on that moment. The mission did not survive because it was invisible. It survived because someone hesitated at exactly the right time. Once the drones crossed that boundary, there would be no second chance to save them. At 3:12, the drones descended again. Both UAVs dropped to approximately 55 meters, settling into a flight profile designed for physics rather than speed. Below them stretched the frozen steppe, hundreds of kilometers of empty terrain. Above them sat one of the densest air defense networks on paper. These systems were built on the assumption that targets would fly higher. At this altitude, those assumptions collapsed. Most ground-based radars in the region were mounted 8 to 10 meters above ground level. Against a target flying under 60 meters, the radar horizon shrank brutally to 30 kilometers at best. Beyond that, radar energy did not fade. It overshot completely. The signal passed above the drones, never touching them. The route exploited that limit. The drones followed a pre-planned corridor carved between overlapping coverage zones. In wide areas, the margin reached 12 kilometers. In the tightest sections, it narrowed to 7 or 8 kilometers. At cruising speed, a navigation error of just 15 seconds would have pushed them into detection range. They never drifted. The corridor was not empty. A Russian patrol helicopter lifted off during the transit to monitor infrastructure after recent sabotage. It was not searching for drones, but its presence changed the environment. Radar operators began scrutinizing faint returns more carefully. For several minutes, the corridor became dangerous. A medium-range radar registered a flicker, weak and intermittent, at the edge of detection. The signal appeared, vanished, then reappeared several kilometers away.
To normal ops.
Atmospheric conditions were unstable, with cold air layered over warmer ground, bending radar energy. This created false contacts that mimicked movement. The operator watched the scope. The track held a consistent heading. That was unusual, but not decisive. Escalating would mean scrambling fighters and explaining why a ghost contact justified the resources. The signal was logged as low confidence. The radar returned to higher priority sectors. The drones continued forward. They crossed more than 300 kilometers of hostile airspace untouched. They were protected not by invisibility, but by geometry, discipline, and a corridor allowed by the planet itself. At 5:10, the airspace changed character. Ground-based defenses could not be placed across the empty steppe due to a lack of roads and logistics. Instead, the task of protection shifted upwards. 2 Russian fighter jets were already airborne, holding a wide patrol pattern at around 11,500 meters. They swept back and forth across nearly 160 kilometers of empty terrain. Their mission was endurance, not interception.
Aircraft.
Each aircraft burned close to 2,800 liters of fuel per hour, watching for something that was not supposed to be there. Their primary radar could detect large aircraft hundreds of kilometers away. Against a target the size of these drones, the detection range collapsed to almost nothing. The real danger came from infrared sensors. The fighters' passive sensors scanned for heat signatures that did not belong. The drone engines were small, but they exhausted gases at nearly 600 degrees Celsius into air colder than -10. Against the frozen ground, that temperature difference was unmistakable. For several minutes, the geometry favored the drones. They were low, under 50 meters, and far behind the fighters. They sat in the blind zone of the jet's forward-looking sensors. Then, the patrol pattern began to close. As the fighters reached the end of their route, they rolled into a turn. The geometry flipped. Their sensors now swept directly across the corridor the drones were transiting. The closing speed climbed rapidly to over 750 kilometers per hour combined. A faint thermal trace appeared. It was weak, but real. Filters adjusted and sensitivity increased. The signature sharpened enough to confirm movement. The intercept logic began forming. If the track held, visual contact would follow within minutes.
I see it.
The drones did not
Rerouting
accelerate
auxiliary
or
power
climb.
now.
They executed a programmed course change of approximately 14 degrees, timed to the second. The effect was immediate. The exhaust plume rotated relative to the sensor, stretching into a thin line instead of a bright point. Ground heat flooded the background, and the thermal contrast collapsed. The trace dissolved. The fighters held course briefly, chasing uncertainty as their fuel margins shrank. Nothing returned. The patrol resumed its pattern. The drones had survived by slipping through a narrow window of geometry and timing. A small change in angle was enough to turn certainty into doubt. The destruction of that ship was not the result of poor training or inferior technology. Every system worked. Every order made sense in the moment. The crew responded exactly as doctrine demanded, yet the outcome was unavoidable. The real failure happened long before the drone ever launched. It happened when assumptions were written into steel. It happened when designers believed one gun was enough, and planners assumed threats would always be fast and obvious. Against missiles and aircraft, those assumptions held. Against a slow, low, deliberate attacker, they collapsed completely. The drone did not overpower the ship. It simply went where the ship could not shoot. That is the uncomfortable lesson of modern warfare. Victory no longer belongs only to the side with more power or better range. It belongs to those who understand physical, design, and human limits, and are willing to exploit them. This is why these stories matter. It is the quiet decisions that make the final explosion inevitable. If you were responsible for defending that ship, what would you have changed? More weapons? Better sensors? Or the assumptions behind them? How many systems in today's militaries still carry blind spots that no one wants to admit? Let me know your thoughts in the comments.